I'm going to eat right in front of you. 1994, AB3. Consider the curve defined by x squared plus xy plus y squared equals 27. Okay? I'm hungry too. Write an expression for the slope of the curve at any point xy. What are they wanting you to do when they ask for the slope? Find the what? I don't know. I don't know. Okay? Now, they'll be a little bit more straightforward. They want you to find the slope, which means derivative, of points x, y, so we know y depends on x. So that's how you know you want dy dx. That's what I'm after, dy dx. This is not a related rate problem. Why would you do it as a related rate problem? We need to be able to tell the difference.
Billy,
Because you're not doing it all
to
the
do it
time.
like a related
If
rate
you're not
problem.
going,
I didn't.
that's exactly right. Don't mention anything here about, hey, consider volume changing over time, or considering the radius changing over time. This is just x and y. They want to know the slope at a specific moment. This is just a straight up derivative. So, but you do need implicit differentiation. So, here we go. X squared, you will get some points, don't worry. xy plus y squared equals 27. I'm going to do implicit differentiation. And I want to find dy dx. I'm going to do everything with respect to x, which means the only thing I need to do implicitly is the y variable. You don't need to do the x variable implicitly. You can just do that one with normal differentiation. So what's the derivative of x squared? 2x plus derivative of xy would be what? You got to use what rule there? Product rule. So it'd be 1 times y plus x times dy dx plus 2y dy dx equals 0.
I get confused when there's like a constant in front of the xy. What is that constant?
So if you had like x squared plus 2xy,
Yeah.
what I would do is go, if you're taking the derivative of that, it would be 2x plus, then I would treat the 2 as just constant multiple rule. So I'd throw the 2 out front and then just do your product rule in the parentheses and distribute the 2 later.
What if we also did dx dy or dx dt?
You're going to have a problem because you did it with respect to time and you weren't supposed to. Okay? Doesn't mean you're not going to get some points. It just means you're not going to get a lot of points. Okay? So now the next step is to solve for your dy dx. So we have 2x plus y plus x dy dx plus 2y dy dx equals 0. You understand? Because this is not a related rate problem. Okay? So now I'm going to get dy dx by itself. So I'm going to have x dy dx plus 2y dy dx equals negative 2x minus y. Factor out the dy dx. Never get the dy dx stuff to one side. Factor out the dy dx. X plus 2y equals negative 2x minus y. Divide by x plus 2y, so we're going to have dy dx equal to negative 2x minus y over x plus 2y. There's your derivative.
That whole thing, like,
3 points. You get 1 point for doing the first step of the derivative correctly. You have to do that first step correctly. And then you get the last 2 points for your algebra, which you don't even have to show a lot of algebra.
So if I did that wrong on the first part where I had
Yeah, because you tried to do it with respect to time. Oh, that's the same. So if they did it with respect to time, how did I do this? How did I do this? I ended up giving 1 point if you did it with the dt in there. Okay? So we got to tell the difference between just a dy dx implicit differentiation problem and a related rate problem, which does use implicit differentiation, but with respect to time. Okay? Part B you still got a shot. Part B and C, even if you screwed up Part A, you still got some opportunity to get some points on Part B and C. So Part A was worth a point, or 3 points. So I'm going to go ahead and erase that, and I know my derivative here is this negative 2x minus y over x plus 2y, which, by the way, you also could have that negative on the bottom. So it could have been 2x plus y over negative x minus 2y. That's also an option. Okay? All right, Part B. Here's the biggest thing that I think you guys are struggling with when it comes to free response, that I've got to get you over this hump. Okay? The hump is this. You don't even know what the problem is. Okay? And until you know what the problem is asking, there's this stupid hump in the way, and you can't see how to do the problem until you remove the obstacle. And the obstacle is, it's simply, you've got to know what the question is asking. That's what good problem solvers do. They understand what they're being asked to solve. I mean, it's like if your boss comes up to you and says, I want you to build this. You got to understand what it is you're trying to build first before you can build it, right? Okay? Or if they come to you and say, we need to figure out how we can do this before next quarter. The first thing you're going to do is try to understand the context of what it is that you're trying to accomplish. It's no different than in sports. If you set a goal, you got to understand what it is we're trying to accomplish. I mean, it's like football. If we want to score a touchdown, well, how are we going to do that? Okay, let's figure out, the context of the problem. We know what defense we're facing, and we understand what's going on. You understand what's given, you understand what you're up against. Then you can actually do some work. So understand what it is you're being asked to do. So when I read this, watch how I read it. First of all, I probably, and I think some of you are trained to do this, but some of you aren't trained to do it, just read it without even trying to figure anything out. So determine whether the lines tangent to the curve at the x-intercepts of the curve are parallel. Show the analysis that leads to your conclusion. Okay? So, right now, that just sounded like Greek to me. Now I'm going to go back and translate the Greek. All right? Determine. Okay, I want to find something. I want to determine something. Whether the lines tangent to the curve. So now I'm talking about what kind of lines? Tangent lines. What does that employ? Derivatives. Okay? So, right there, this lets me know, okay, I'm going to have to do something with derivatives. You might not write that down, but you just might underline tangent and just remember, okay, that means y prime. Okay, and we have a derivative. We have dy dx equal to negative 2x minus y over x plus 2y. At the x-intercepts, I want to determine whether the derivatives at the x-intercepts. Okay, there's something new. What does it mean to be an x-intercept? Y equals 0. That's huge. This problem got a lot easier. Because we're saying y has to equal what when we're talking about these tangent lines. Now they discovered something that I didn't even think about. I'm going to show you what they discovered. Of the curve, so I'm going to determine whether the derivatives at the x-intercept, so when y is 0, are parallel. So in other words, I want to see when y equals 0, are the slopes going to be parallel. What does it mean for slopes to be parallel? Same slopes. Do you understand the problem now? You understand what you're trying to do? Okay, now I just need to show the analysis. Now, here's the way I did it. I said, well, I'm going to find the x-intercepts first. That's literally what I'm going to do. I'm going to find the x-intercepts. How many of you did that? How many of you did that? How would you do that? What year is this?
94, AB3.
Okay, how many of you would find the x-intercepts? What'd you get?
Plus or minus 27.
That's the way I did it. I'm going to tell you, half the class found a better way. And I didn't even think of it. So what I'm going to do is I'm going to plug 0 in the original equation and actually find the x-intercept. So I got x squared plus xy plus y squared equals 27. Watch what happens when I plug 0 in for y. Cancels, cancels. You get x squared equals 27. You get x equals plus or minus 3 root 3. You with me? You see that? That right there, my friends, is a point. My ladies and friends and men and girls. Okay? All right, plus or minus 3 root 3. You got it? That's x-intercepts. Now, I want to show that these x-intercepts are parallel. So what am I going to do with the x-intercepts? I'm going to take 3 root 3, comma 0, because it's an x-intercept, and negative 3 root 3, comma 0 because it's an x-intercept. And I'm going to plug both those points in and see what the slopes are. Now here's what they were like, you don't even need to do that. And I'll show you why. So when you get dy dx, plug in the, let's do the positive 3 root 3 first. So we're going to have negative 2 times 3 root 3 minus 0 over, I'm plugging into the derivative, 3 root 3 plus 2 times 0. What you end up with here is, this one's going to end up being negative 6 root 3 over 3 root 3. These just cancel, those are zeros. And what do you end up with? Negative 2. Sweet, right?
So what if you got -2?
I'm going to show you what they did. Then you do the same thing, dy dx for the other point. Okay, where was your test at? Is it there still? We'll finish it for you. So I think you just have one problem left to grade, right? We'll finish it for you. The homework's on brutal.
Yep.
And then plug the other one in, negative, watch what happens. Negative 3 root 3 minus a 0 again over negative 3 root 3 plus 2 times 0 again. And what you get is 6 root 3 on top divided by negative 3 root 3 on bottom. What do you end up with again? Negative 2. Are they parallel? So if you did it this way, you get a point for showing the x-intercepts, a point for showing both the slopes are negative 2, and then a point for saying, yes, they are indeed parallel. But here's what was magical. Yeah, here's what's magical. What they did is said, well, since I got x-intercepts, they said, can't you just plug 0 in for y into the derivative? And since you're dealing with an x-intercept, y is equal to 0, right? So you're going to end up with negative 2x over what? X. And that means the x's cancel, and the derivative actually simplifies to what? So when y equals 0, this is always true. So when you're dealing with an x-intercept, when y equals 0, the derivative is always going to equal negative 2, and you just say, hey, when you're an x-intercept, the derivative always equals negative 2, therefore they're parallel.
So you get the full 3 points.
And it's a lot faster. Did you show some stuff? Did you show they equal negative 2? You get a point for being parallel. You just,
Yeah, I found parallel and
yeah, you and Billy did the same thing. Plug 0 in for y. And, yep, y equals 0, there it is. Yep, that's it. That's good. That's cool. Just
So
once.
if I need to plug it back in, like, I just have that position, this is what we got.
Okay, I'm going to give you plus 2. Plus 2. Wait, did you use like actual decimals? How did you get point? Why did you get 1 point?
Because we actually took like the square root.
Oh, that's fine then. No, that's fine. That'll give plus 3. All right. Any questions? Does that make sense? Yeah, that's fine. All right, are we good? Is that making sense? Tracking? Let's go to part C. Part C here. Part C is actually, I think, a little bit easier than part B, if you know what's asked. I want to make sure we clarify what is being asked here. So listen carefully. Okay? Let's talk about, first of all, a horizontal tangent line. What is a horizontal tangent line? When the derivative equals 0. When will a derivative equal 0 when you're dealing with a fraction? When the top is equal to 0. All right, let's talk about vertical tangents. To find a vertical tangent, you want to know where the derivative is. Undefined. When will a fraction be undefined? When the bottom equals 0. How many of you are kicking yourselves right now? All right? So all I want to know, since the derivative was this, was dy dx is equal to, what was it? What was the derivative? Negative 2x minus y over x plus 2y. Correct? So I want to know when you have vertical tangents. Vertical tangents is when the derivative is what? Undefined, which means the denominator is 0. So I'm going to take that. Right here is 1 point.
wait, I had
Let me have x equals negative 2y. That's a point. So far. That's a point so far.
Yep.
Or you could have had or.
Yep. Y equals.
Oh, okay. Cool.
Y equals negative 1/2 x.
You can plug it back.
Depends on which one you solve for.
That's why you gotta go plug it back.
Same thing, isn't it?
Yeah.
Now what do you do with it? How do you find points on a graph?
Plug it back to the original.
This is doing a system of equations from 9th grade. So here's the problem. You have two variables.
Plug it back.
So what I'm doing is remember substitution and elimination from 9th grade? Remember elimination method and substitution method? We're actually using substitution method. We have an equation with two variables here. Our original equation is an equation with the same two variables, so I can substitute into one of those equations to get one variable instead of two and solve for it. So by replacing y with negative 1/2 x or replacing x with negative 2y, you're going to get it down to one variable. Now, which one would you rather use? X equals negative 2y or y equals negative 1/2 x? I'm going to use the x equals negative 2y because it's easier,
I did the other one.
but you'll get the same answers. Okay? So if I do that, I'm going to have x equals negative 2y be negative 2y quantity squared plus negative 2y times y plus y squared equals 27. So I have 4y squared minus 2y squared plus y squared equals 27. My 4y squared minus 2y squared is 2y squared. 2y squared plus y squared is 3y squared equals 27. Look how easy this is. Y squared equals 9. What's y equal then? Plus or minus 3. Now I take those answers, go back to here or here, whichever one you did. In my situation, I'm going to go back to the x equals negative 2y. Now, the reason you don't want to go to the original with this is if you go to the original with this, you're going to actually double up your solutions because you're going to be resolving for x. But we know x is related to y, so these are our two y values. That's it. There's only two y values. So I'm just going to plug into x equals negative 2y and get my x values. By the way, that's a point also, or if you got the x values. Now the x values, what are the x values going to end up being?
6 negative.
Be negative 2 times 3, and it'd be negative 2 times negative 3. So you're going to get negative 6 and 6, and make sure they match up. The negative 6 goes with the what? That's the final point. Ready? It's negative 6 comma 3, and then it's 6 comma negative 3.
Yeah, plug it back.
What if you got it back?
You got double 4 points?
Yeah, I'm just like,
Orange.
No, just take that one.
What if you messed it up and plugged it into X
I still get plus 5.
Huh?
Yeah, I plugged in with what I got for X
Like the wrong place.
and I got negative 6. For each problem is 3 points.
Sometimes. They're not built that way anymore.
See,
But you
Way
can
they
have
used to.
how much is CB?
CB3.
Yeah,
And
because
then you get 3, you get a point for doing this.
you only had.
Ready? Patrick, get a point for doing this. You get a point for solving for x or y. And what'd you get for x's?
Because you did. See, you showed.
Did you get 6 and negative 6?
No,
Plug it in.
I put the X into the Y on accident for the formula.
Oh,
So
I can
put
give
in-
you it. Oh, I see what you did.
See,
I can give you that plus 2 off that.
you plugged in.
What if I
Right.
just had no idea what was going on and I just we tried?
You tried.
You 3 and 3.
Yeah.
You then.
Yeah, that's nothing. Yeah, that's nothing.
Yeah, you use your point.
Nice try.
Okay.
Still got a 4. That's a problem. I got
Yeah.
I thought it was